No.
Greetings, everyone, and welcome to today's webinar, How to Build a Resume Evaluator using SingleStore and OpenAI. My name is Matt Brown, and it is my pleasure to be your moderator today. Ahead of our session, there are a few logistical pointers that I'd like to share. First of all, today's discussion will be recorded for your convenience. And second, you are in a listen-only mode for the duration of the webinar. However, you're encouraged to engage with us by submitting questions throughout the session. You can do this using the Q&A functionality at the lower portion of your Zoom console. We'll answer some of these interactively as they come in, and others we might save for the end when we do a live Q&A session with our panelists. If this is your first time joining a SingleStore webinar, heads up that we present weekly webinars demoing data and AI use cases and new technologies. And if you click to the next slide, you will see that next week on Monday, we will be presenting Beginner's Guide to Gen AI, LLMs, RAG, and much more. During this, we'll be presenting the basics of LLM development, how to harness retrieval augmented generation to incorporate Gen AI into your future projects. If that sounds interesting to you, you can RSVP right now. There's a bit.ly link on the screen, bit.ly Beginner's Guide Gen AI webinar. I hope to see you there. You can also use that QR code, take a photo or a screenshot of that QR code, and that will take you to the same place. So back to today's topic, we have fantastic technical experts. Like I said, we will answer as many questions as we can, and we'd also love for you to try out today's technology. So if you click to the next slide, you'll see that we're offering a little promo today. Anyone who tries out SingleStore today, the technologies that we're going to be showcasing, will be entered for a chance to win brand new branded AirPods Pros. All you need to do is hit that link that's on your screen. It's the bit.ly OpenAI Resume Evaluator raffle. I'll put that in the chat in a minute as well. Or you can use that QR code, take a photo or a screenshot of that that's on your screen. And all you need to do is log in to SingleStore. We have a free trial if you're a new user, or if you're an existing customer, or if you have an ongoing trial, you can just log into that existing account. We will be checking the folks who have logged in, and we will announce a winner by the end of today's session. So stay tuned for that. Let me introduce our speakers. Vishwajit is an enterprise solutions engineer at SingleStore DB based in Kolhapur. He's worked previously as a data engineer and as an analyst, and he has extensive skills with LLMs, ETL, vectors, OpenAI, and much more. And then Aditya is a cloud solutions engineer at SingleStore DB. He's based in New York City. He's previously worked as a DevOps engineer and a data analyst, and he has extensive expertise with cloud databases, Kafka, and engineering generally. Please welcome both of them. Aditya, I believe you have the floor first.
Awesome. Thank you so much, Matt, for the warm welcome. And I'm excited to get things started with you all and present this exciting webinar related to OpenAI and SingleStore for a very, very niche HR use case. So before we even do that, I think it'd be very important for us to just dive into SingleStore as a database, provide a high-level overview of the actual database architecture, and then we can dive into, from that point, some vector database fundamentals, specifically as they relate to the Gen AI applications that we've seen popping up in the recent past, which we'll also dive into today for this demo. So just real quick before we get started, I just wanted to set the scene and let everyone know at a high level what we'll be actually learning today. So in the demo, you will see Vishwajit actually running a notebook to ingest a resume in PDF form, extract its textual content, and use OpenAI and LLM to actually transform that textual content into vector embeddings. Now, SingleStore is a database that can handle vector embeddings and do vector functions across this. So we'll leverage SingleStore as the main data store and the computation layer here to find actually relevant resumes based on an input job description that we will be essentially typing in ourselves. Many of you might have seen the quick demo video that was shared on LinkedIn and things like that. So we actually have a pretty cool UI where we can drag and drop resumes, drop them directly into the portal, and it'll give us the relevant searches from that. But we also have the underlying notebook that we'll run through the code for and show you how it's done behind the scenes. So let's get things started. An introduction to SingleStore. For many of you that are unfamiliar with SingleStore or SQL databases in general, it's totally fine. We'll kind of start from a level 100 here. What I'll start off by saying is that SingleStore is a relational SQL database that is scale out and horizontally distributed. And it is a database that is built to transact, analyze, and contextualize data in real time. Now, what we've seen historically is that you typically needed two different types of databases to handle two distinct types of workloads, and those are transactions and analytics. What SingleStore actually does in its patented engine and table type is it combines both of these workloads into a single environment, single engine, single table type. And we also have the ability to do vector operations on top of that. So let's start here with the transactional layer. How are we able to do really fast transactions? Well, we have super fast ingest pipelines through which you can load data from a variety of supported sources in a parallel format. We follow an MPP or massively parallel processing architecture. So we are distributed SQL and we are horizontally scalable. So you can scale out your system and add more parallel processing power and computation when you need, lower latency queries, higher concurrency support for an application, or even, higher throughput of ingestion. So it's a little bit about the transaction layer. From just a columnar perspective, this is what we call the analytics part. We're able to do large scale aggregations on petabytes worth of data. And we're able to do this not only on your traditional RDBMS SQL type data types, but we're also able to do it on unstructured and semi-structured data like JSON, full text, geospatial, time series, unstructured data analytics. So we can take, NoSQL type data, we can add relational SQL capabilities on top of that, index it, and do large scale aggregations on top of that. Lastly, with vectors, SingleStore has always supported vectors since about 2016 or so. But obviously, with the big boom in generative AI recently, we've started branding that more. So we have the ability to do semantic search and keyword search. We're actually the backbone we're the backbone of a lot of generative AI applications that do like image and text matching and things like that. And we have direct ways to actually integrate with the database using Jupyter notebooks that are built into our cloud portal. So that's something that you'll see showcased today. I like to consider this kind of the bread and butter of SingleStore. And this is a really deep dive into our database table architecture and what makes us really fast and performant. You'll see here that we have a 3-tiered storage architecture. We have the memory layer, persistent cache, otherwise known as local disk, and a cloud object storage. So I want you to consider this in the context of memory being your hot data, persistent cache being your warm data, and cloud object storage being your cold data. In the universal storage table, it is a table type that is built to handle very fast transactions. So think about, apps that require really fast lookups on single rows of data. They need really fast inserts and the ability to actually change data frequently using updates and upserts and things like that. So SingleStore universal storage table is super fast for those kind of operations, but also extremely performant for OLAP queries such as aggregations and certain functions across large petabytes or terabytes worth of data scale. The the pattern that a single insert follows here in SingleStore universal storage is that you ingest data first into memory. Because it hits memory first, those inserts, updates, deletes are super fast. It then flushes to the persistent cache or your local disk thereafter, pretty much asynchronously. So it actually gives you the ability to do analytics on data as it's freshly being streamed into the database. And that's something that's pretty rare. Right now, typical analytics applications would have to wait for a batch processing job of some sort that may take, minutes to hours to actually fully process. By the time it does, that data often becomes stale and you can't get any kind of business insight out of it. In SingleStore, you can run those read queries, those analytics queries as data as they are freshly being inserted. So within our persistent cache layer, we have significant compression algorithms where it gives you up to 80% compression. So let's say that you put a terabyte worth of data. Realistically, in SingleStore, it's going to boil down to like 200 gigabytes. So not only are you saving on expensive memory costs, but you're also saving on disk as well. And another benefit is that you don't actually have to do any kind of data movement or ETL between your transactional analytical layers because all of your data is sitting there in one single table type. All of your operations can just hit that single table. There's no duplication of data. There's no data movement. There's no in-database ETL or external database ETL. So it's really designed for kind of what we call an HTAP or a hybrid transactional analytical processing workload. Lastly, we have this cloud object storage layer, which essentially takes an asynchronous replica of everything in your memory and local disk. So it adds an extra layer of resiliency of disaster recovery, if you will, but it also allows you to store unlimited data past your limits in your local disk. So, if you had an application that needed to store years worth of data, but you only needed to query on maybe like the last month worth of data, we would just want to make sure that your last month's worth of data can fit in the persistent cache and everything else can just flow to the object storage layer. Now, from just a MPP architecture standpoint, we have aggregator nodes and leaf nodes that can scale out, and each of these have very distinct functions. So the aggregator nodes contain your threads for query execution. They essentially pass on the workload and do routing to your leaf nodes here, which actually store all of your data, execute all of your SQL statements, and send it back to the aggregator, which then sends it back to the user or application. So when we talk about scaling up, it just means making each of these individual machines larger. And when we talk about scaling out, which is the horizontal version, it means adding more machines in parallel to give you more processing power. So just a quick summary of some of the key product capabilities that we covered. We talked about the universal storage table, the ability to do both OLTP and OLAP within a single table, how that facilitates pure speed in terms of transactions, analytics, and soon you'll find out about vectorization as well. Fast ingestion, fast writes to SingleStore, unlimited storage, so the ability to actually separate your compute and storage layers, the ability to do that with multiple different data types, like unstructured and semi-structured as well as relational data. And one thing that I forgot to mention too is that we are a hybrid solution. So we are multi-cloud. We can be deployed in any of the three major clouds or on-premise or self-hosted. So it's a pretty unique solution that you can actually leverage, on-premise or in the cloud. And lastly, we have GenAI Jupyter notebooks that you can actually use to build these kind of applications. So that brings me to kind of the bulk of this slide deck right here, and probably what most of you guys are interested in learning about is the vector-based database side of SingleStore. How does a relational SQL database like SingleStore that is built for transactions and analytics actually handle vector data types and do vector functions and do semantic search and keyword search and all of those other cool things. So I'll start by explaining that vectors do not always equal context. When you build a generative AI application, what you want to do and what you definitely need is a contextual database. And let me just start by naming some requirements that you would need from a contextual database. So I think the first one is a given. Your database absolutely needs to have all data relevant to a specific company and not just public data that maybe an LLM has been trained on. You need to be able to join vector data with transactional and analytical data and do hybrid searches where you can actually get more contextualized and accurate responses from doing these searches. You need to be able to connect and ingest data from a variety of different sources, whether those are like, PDFs or Slack or, external catalogs and things like that. You need to be able to run both on-premise and on the cloud, and you need to be able to quickly prototype and deploy. So how does SingleStore help with all of that? Well, we have vector semantic search and keyword match with built-in functions like dot product and Euclidean distance. We handle both transactions and analytics, like I mentioned, so you can join your vectors with both of these data types. We have pipelines for fast ingestion on the fly. So we support sources like cloud storage or Kafka, where you can load in data with millions of events per second, while also potentially transforming that data as it lands to the data target. We support a variety of data types, so you can do hybrid searches. We run on-premise and cloud, and we have notebooks where you can actually deploy with Python and SQL. So it looks like we're getting some questions in the chat. Maybe Vishwajit or Matt can respond to those as I walk through the deck, just for in the interest of time.
Absolutely, Aditya.
Awesome, thank you. So let's just walk through a typical flow of what an enterprise using AI, generative AI data or vector data might look like. So let's say that you have an application that feeds some end users. You use an OLTP database, maybe something like a MySQL or a Postgres for a SQL server. And then on the flip side, you have internal enterprise users. These might be your business decision makers. These might be data scientists that are trying to derive insights from how your application is performing. So you need to add in an analytics layer for which you'll need an OLAP database. Now, in order to get data into a format that is structured for OLAP type queries, you probably have to do some complex ETL batch process, transform that data, ingest it into the OLAP database or data warehouse, maybe like a Snowflake or Redshift or BigQuery or something like that, and then run your reports and dashboards off of that. Now let's add something else into the stack. Let's say that you want to add in a vector store database because you want to pull in relevant company details and information from Slack and Google Drive and support tickets and your GitHub and other sources, and you want to actually do some sort of, ML, AI type predictive analytics on that. As you can see, you're adding just another layer here. You already have an OLTP database, you already have an OLAP database, and now you're adding another vector store database. So many of you might know that there are a lot of specialty vector databases out there in the market right now. Some of the most common names you'll hear are Pinecone, Quadrant, as well as a couple others. So these databases are extremely new. They essentially are very memory hungry, and they have often long indexing times and very expensive indexing requirements in order to actually store vectors. And there are typically limitations around the actual number of embeddings you can store, the operations you can run in terms of upserts and deletes and inserts and things like that. And what we've also seen is that these specialty vector databases are not necessarily enterprise ready. So because they're so new, they're typically missing features related to high availability and resiliency, related to security, like role-based access control and things like that. And that's really where a solution like SingleStore comes into play, where you can essentially mitigate this stack and consolidate it into a single database that can handle all of these operations at enterprise grade. So there are essentially 4 steps to vectorize data for an application, and you'll actually see this happening live within the demo that we show. The first step is to prepare and tokenize the data. You can then chunk and create embeddings using an LLM, maybe something open source like OpenAI. You need a vector store that can actually store this data, something like SingleStore, and then you need the ability to, once store that data, run your vector functions and search operations to do the keyword search and semantic search. So you need a database that can support those. Now, I'll talk to this slide more in the context of 2 separate approaches. The first is just asking an LLM a question without context. And the second is using a RAG approach, or retrieval augmented generation approach, to actually where we are actually adding in the database layer. So consider this top half here, just asking the question to an LLM like OpenAI without any context. And then the overall picture here is the RAG approach. So let's say an end user visits an AI application and they ask it a question, something like generate an article for my new product. That AI application will essentially vectorize the question, send it without context to OpenAI. It'll respond, there'll be a response, and then the user will get a response based on that custom prompt that they typed in. Now, this is fine, but essentially what happens is this LLM is only trained on the information that it knows, and not maybe the most up-to-date information, and not company-specific information that would provide it more context to the question. So things that I mentioned before are like PDFs, docs, tickets, forum posts, things like that are super relevant to an organization, and that needs to feed into the actual answer that's being delivered to the end user. So let's use the RAG approach here, where instead of feeding that question directly to the LLM, we're first feeding it into the database. So the question is vectorized, it's stored in a vector form, and it's filtered based on the context of that question. Now, in SingleStore DB, we support a native, blob data type that is able to store vectors. And we actually have coming up in our new release, a new native vector data type. So that's a product enhancement that we'll see coming up soon. So once that data is in SingleStore DB in vector form, we will actually do some functions such as dot product and Euclidean distance to actually match similar vectors, get a relevancy score. We can essentially, order the relevancy score by the closest or the highest number and rank them, and feed those back to OpenAI, the LLM, with context now. Now, this will actually generate a response that is more accurate, contains more trained data that is relevant to a company. And it's pretty much the way that the industry is going right now with the RAG approach. So we actually have an exact, we've done the same exact thing within SingleStore DB, where if you actually go into the portal, you'll see something called a scroll bot. So we have a chat bot where you can ask it any question about SingleStore DB, and it essentially indexes on all of our internal company information, and it provides an answer within seconds using this exact RAG approach described here. So what's the difference between a vector operation that can be run within a specialized vector database, as well as something that can be run within SingleStore DB? And I apologize for kind of the graininess of this screenshot or code, but hopefully you can follow along. So I've outlined 3 examples here where we're doing number 1, semantic search with vectors. we're doing a dot product of two vectors and finding a similarity score. So that's this middle section right here. We're mixing and matching different kinds of data. So we're joining the vector data with movies with tags, which is transactional data as well. And lastly, we're doing analytics on top of that, where we're doing these kind of rounding and average functions to find rating matches that are relevant. And this is done over petabytes of data, as you can see, in 728 milliseconds. We found the title of the actual movie, we found a match score, and we found the average user rating just in a couple seconds using a complex SQL query like the one you see above. So this just goes to show that, obviously we can do the typical search vectors that a lot of the vectorized databases can do, but we can add other capabilities on top of that to add more contextualization around your end answer. So these are just some stats that we've seen from a lot of our customers that currently use us as the backbone for their generative AI applications. They've seen a 400x improvement in query performance, the ability to do hybrid searches in less than 1 second. And this includes with joins and some of the other complex operations that we saw on the last slide. And we're adding new native functions in every major release. We have first-class vector support and 10+ supported native functions right now, and we're continuing to add more on our roadmap. So things that are coming up down the line include ANN, so approximate nearest neighbor search, which is something that'll be super cool. And I think we can all agree that right now, with the boom of generative AI, English is the new SQL. And in order to actually power these applications and interact with them, a database needs to be able to take text in English format, take speech, even pictures, images, videos, transcribe that to SQL, have best-in-class vector support, and drive the ultimate answer back to the application. So with that being said, I will now hand it off to Vishwajit for kind of the juicier part of this presentation, which is the actual demo itself. So Vishwajit, I'll let you take the floor from here.
Thanks, Aditya. That was a well-needed explanation and information, right? Let me share my screen quickly. If you just...
Sure. Would you like me to stop the screen share?
Yes, please. So whatever just now Aditya told us, right, we're gonna see all of it in live action, right? Aditya, just confirm once you once you see my entire screen.
Yes, I can see your windows with few different tabs, and right now we're on the Evaluate Candidate portal.
Absolutely, absolutely right, guys. Let me just quickly go to the architecture before we dive into the exact demo. So what we for this specific demo of evaluating bulk resumes, right? What we are doing, we have a data source. It could be either your direct PDF file from your local system or the URL of a PDF file. You can even provide a database connection from where you can actually extract the candidate information and pass it to, you can just ingest it into SingleStore while generating vectors of that information. Then you take the job description, again generate this vector, do a dot product in SingleStore, pass the results to LLM, and get a very good evaluation for each candidate, right? So without wasting much time, let's just dive into it. Just quickly. Give me a moment. Right. So this is probably most of you have seen this in the LinkedIn video which we uploaded. Let's see it in live. What we're gonna do, we're just gonna take any one resume for now, right? And we're gonna just process it. So what is happening right now in the behind is we are taking the resume, we are extracting its text using one of the Python libraries, PDF Miner. And what we are doing, we are passing the text to LLM and asking it to give us the information into the required format, right? Now I'll show you a glimpse of how it actually looks, right? If you take a look at this, right, we asked the LLM that give us the information in this specific format. And by doing this, we can actually ingest the data. You can see the log here that we have ingested the data into one of our tables. Now let's do one thing. Let's go back, and the important part where we actually perform dot product, let's just see it in action. I'm just going to copy one of the simple JDs which we have created for this one, right? I'm just going to post it. I'm going to keep the similarity percentage or threshold to 85%, and let's take top 5 results. Now what, as I explained while we were talking or taking a look at the architecture, right? We take this job description query. It could be of any size or even more descriptive, and we're going to generate its embedding using the same model we used for generating the embedding for our resume. And then we're going to pass it to SingleStore, do a dot product, get the top ranked resumes and pass it to LLM, right? If you take a look at this, we extracted the information and we put it into SingleStore, and this is the evaluation we got. So you like right now we have a lot of resumes present into the database, and out of them it took the top 5, right? You can of course increase the similarity threshold, that is the result of dot product, and get just the top results which you require. If you can just take a look. Now let's go into the backend and actually take a look how everything happens, right? Before that, I hope you all of you have signed into SingleStore portal. And what you can just do, go to the SingleStore gallery page on your portal, just go to the gallery. And if you scroll down just a little bit, you'll see something called Resume Evaluator. Just click on it, and the notebook should be ready for you to use, and you guys can follow along, right? So this is what we're going to see in the notebook. We're going to take a PDF. We're going to extract the information. We're going to put it into SingleStore, and we're going to pass the ranked resumes when we do a dot product using job description and the vectorized summary of the resume, right? So first, you're just going to have to go ahead and create a database. If already not, let's run this, right? So right now what will happen, we are just creating a database and a table. In table, all the information which we are extracting and the resume summary. Now this resume summary is not from the summary section of a resume. It's a summary which we ask LLM to generate it for us. We'll see that also in the next part, few functions, right? And just install some dependencies. As I said, we are using PDF Miner and OpenAI. So do a pip install on them, import all these libraries. Once you do, it's gonna you have to provide your own API key, right? We already have one, so we just gonna enter that, right? And then we are using a function called get embeddings. Basically, we're gonna pass our entire text to this, and it will generate us embedding for us using text embedding ADA 002, which is OpenAI's very strong model for embedding, right? Now the print, this function is mostly related to extracting the data from a PDF to a text format. Here, what we are doing, we are just, if you are providing an URL, we are downloading that PDF file into a temp file. If not, if you're providing a file path, we will directly pick up the PDF file. And what we are doing, we are just cleaning or extracting the text using the extract text function from PDF Miner, and we are doing some cleaning, right? For example, we are not removing @ because your Gmail or any email address in your resume will have @ plus for your phone numbers, dot for the gmail.com or outlook.com in your email, and / is for if you have provided your LinkedIn URL. We do not want to miss that, right? Once we have this clean text, we have another function called a P info extractor or personal information extractor. You can always read through the markdown cells to understand it better, but we have a time constraint, so I'm just going to walk you through this. This is a major function, but as I said, we are not using any dedicated library to extract the information. We are purely using LLMs. So this comes under prompt engineering stuff. So we have created a prompt where we ask the LLM from the above candidate's resume text, which we will be passing over here in the prompt, extract the only following details, right? We are asking it that return name, email, phone number, and in this specific format. I will again take you guys quickly to the to the information which we extracted, right? If you take a look here, like name, email, phone numbers, years of experience, right? That information gets extracted by asking the LLM, right? Which is much better, I would say, rather than having your own parser based on NLTK libraries or anything. Once you have that, we get the information, we extract the information because using colon as a separator, that is how we have expected the data, right? And here I'm setting the temperature and max token to 700 and 0.5. Depending on your requirement, you can absolutely change this. And I am asking the LLM, I'm telling the LLM, I'm giving LLM a persona, right? That you are a helpful HR recruiter, that this gives us a much better response rather than just asking it to be you are a helpful assistant, right? Once you have your data into this specific format, we're going to pass it to the add data to database, right? So this is a function where we are actually adding the data into the database. The one, basically we are taking the input dictionary from above function and ingesting it into the our table, right? Resumes profile data. Here, one thing to note is we are using insert statement because we are doing JSON array pack. The reason for this, our embedding column, if you remember the DDL, right? We are setting the resumes embedding to blob, right? Rather than converting them explicitly using a Python function, you can just use our inbuilt SingleStore's inbuilt JSON array pack function and pass your embeddings in it, and rest will be taken care of, right? So once you have that data, we just write into it using this function. The next function is search resume. Once you have your data and you get your query, you want to do a dot product, right? That is what this function does. Here, what we first do, we take the input query or a job description as an input, we get its embedding, and then we create a SQL statement of dot product, right? Here I'm selecting names, a resume summary, so that we actually we can pass the information to LLM on which it has to evaluate, right? And then we do a dot product of the job description embedding against the resume embeddings which we have stored earlier, right? And for this specific notebook, we have set the limit to 5, but in our application, we have passed the parameters for similarity score and the limit both, right? You can modify this as well. Once we are done with this, the major function is evaluate candidate, right? Like once you create the embeddings for both resume and job description, you do a dot product, you got just imagine you got out of 1000, you got top 100. And now you want top 10, I would say, rather than 100, and you want to evaluate, right? So what we are doing, again, some prompt engineering stuff. We are asking, we are creating a prompt. What percentage of the job requirement does the candidate meet for the following job description, right? And of course, we created again some similar response pattern of to get the evaluation of our resumes, or whichever like. No matter how many we have, we can always generate, right? Like let's say you get 10 or 20 resumes, you can generate the evaluation for them, right? Now, in real time, we're going to see, I have put the GitHub link for my resume, and we're going to, right, I'll show you quickly that there is no data first, right? In our resumes profile data. Yeah, there's no data. And we're going to rerun this. Okay. Just a second. Oh, I'm so sorry. I forgot to run the functions. Let me quickly do that. We have this, run this, right? Make sure you also run all the functions, and if you have any doubts about a specific function, we have made sure that we have detailed markdown cells for each of the function, and you can do this. The very good thing about this, you can create something called, we have something called external functions. You can create external functions of this embedding, and you can ingest the data in real time. So you're ingesting your data with while creating vectors in real time, rather than doing a batch processing for generating the vectors of your data and ingesting into some another table, right? Now let's take a look at our data. So I have just ingested my own resume. So you'll see the information extracted, right? My name, my email address, my phone numbers, years of experience. This still needs some work. Like you can fine tune your prompt as per your requirement, the skills that it extracted, and then the resume summary. As I said, this summary is not from the summary section of my resume, but the summary of my resume as a whole. It even extracted the profile name from the latest profile name from my resume. And this is how our embeddings look like. As I said, we are storing them using JSON array pack. So they are getting converted into byte format, right? And now let's take a look at this. I'm just going to copy this. Okay. We're going to pass any data. Let me just go here, right? I'm going to copy this. Any job description you have handy, right? And we do this and we run the evaluation, right? Now, right now it is saying the candidate meets 100% of the requirement, but of course, based on your job description and the number of resumes you have and the quality of the summary or the quality of text you have for your resume, which you are passing for evaluation, that will make the difference into the output of this, right? And once again, if you just guys want to see something different, I'll show you an example where you don't get anything, right? I'm just gonna say MBBS doctor, not sure. Okay, let me just add doctor with medical experience, right? And I'm just gonna submit. You're not gonna get anything because it will not have any match, right? The dot product will return 0. But if I have some profile with clinical database experience. So let me just show you. I'm showing you this so you can read through the evaluation. Just take a look at the evaluation which you get, right? So we have one candidate. This resume is totally downloaded from one of the job portals in India. So if you are present, Sohaili, this is total coincidence, right? But if you guys take a look at this, right, you get a pretty decent evaluation comparing how, and the SingleStore will help you do this very, very fast, because rather than just going right now, what is happening is people take the data and then do a batch processing to generate the vectors for this. But with SingleStore, by using our external function or even our notebook feature, you can actually do this in real time. So you get your data, you create its embedding, and you ingest everything in the same time rather than running a batch job later on, right? I hope you enjoyed. Let's go back to our slide deck and take a look at the summary quickly. All right. So we saw how intelligent embedding generation is done. You can use any model of your preference. OpenAI is one of them. Cohere is there. Then Hugging Face is as open source is available. And Aditya showed a very good example in deck, which you will get once the session is over, like SingleStore DB as an analytical engine. So not only vector, but even analytical capabilities of SingleStore will come in handy while doing a hybrid search in your GenAI app, right? We saw like dynamic similarity scoring with dot product and in-depth candidate evaluation. Like you can have like thousands of resumes which you see every day on LinkedIn, right? For a single position, you get more than 1,000 applies, and this will help to solve that problem, right? I hope all of you enjoyed. We are open to any questions you guys have.
Awesome. Thank you, Vishwajit. We have more questions than we could probably ever answer in a session, but we still have a few minutes, so keep those questions coming in and I will feed them to our panelists. We'll now start the live Q&A portion of our show. And you can participate by, if you haven't already, just check out that Q&A button at the bottom of your Zoom. One question that I see here is about if multiple resumes are fetched simultaneously, do you have a problem with interaction with the LLM, given that LLM has a token limit? Do you have any suggestions around something like that?
Yes. Let me take that, Matt. So when you have multiple resumes, right, you're not giving everything in one go, right? So you are doing multiple APIs call when you're passing. You take one PDF, you extract the text from it, and then you pass it to LLM to first extract the data. And when you do a ranking using SingleStore dot product, you use those ranked resume and the resume summary in this specific webinar's context, and you do again an API call, right? So you're not actually overloading the API. You're making an API call for each resume, and most probably your token limit will not, at least for me, it did not exceed more than 5,000 tokens, right? So that it will be very cost effective, because OpenAI charges 0.0001 per 1,000 token, right? So that's 0.0005. I think it's very less, right, Matt, in dollars?
Yeah,
right?
yeah. I've heard, Akmal say in the past that he's worked with a lot of different models and LLMs, and I think he said that he loves OpenAI in terms of the quality versus the price. He thinks it's just a great value. I know there's other, there's open source options out there like Llama, Hugging Face, Vishwajit. Have you worked with any of those? I can't remember.
I have worked with Hugging Face, but not Llama. Hugging Face
Okay.
and Cohere I have worked with, yeah.
And how'd you like it?
Yeah, I liked actually Cohere's better, actually much better than OpenAI, because the retrieval capacity of the command nightly v3 of Cohere is much better compared to OpenAI's ADART 002, right? I'm talking about the embeddings, specific embeddings.
Got it. Cool.
And okay, someone is asking, does LinkedIn also have AI evaluator? What's the difference between LinkedIn AI evaluator versus SingleStore evaluator? So SingleStore is a database, and this is just an application, one of many applications which you could build on top of SingleStore. And LinkedIn, as we all know, it's a social media platform for networking for professionals, right? And I think that answers.
Yeah, I saw another one, Aditya. I wonder if you could answer. I think I saw you going after it, but I bet you the community would love to hear it. It was about JSON, and I think it was something like, how did you get this into JSON? And I feel like there's also an opportunity to just talk about single stores generally, JSON and Mongo Kai and whatnot. Aditya, do you want to talk about that a little
Sure.
bit?
Absolutely. So I think within what the question was referring to was within the dot product function that Vishwajit used, there was a function called JSON array pack, which actually takes the input JSON and converts it to a blob. So on that note, like Matt mentioned, we are a multi-model database that supports JSON data types, and JSON analytics is something that we've been building out and doing a lot of engine optimizations for within the past year. So we actually have a native Mongo proxy API. If you guys are familiar with MongoDB, you'll know that it's quite fast for transactional type workloads, but pretty slow for any kind of analytics. So in SingleStore, what we have the ability to do is just point your Mongo running application directly to SingleStore. We have a native endpoint for Mongo, and the product is called Kai, in case you want to look it up. It allows you to run very fast analytics on your Mongo application without actually having to do any kind of code change or ETL. So it's kind of just a point and shoot based mechanism to SingleStore. You can run fast Mongo analytics, and you can essentially just augment your transactions layer on MongoDB with an analytics layer on SingleStore.
Awesome. Aditya, I want to stay with you for a second. I've seen a couple questions about, is SingleStore available in Azure and AWS? Can I do on-prem? What's the free trial versus the free tier? What are the scalability features of SingleStore? So I wonder if you could just do and especially since you see so many different trials and customers, maybe starting with the free trial and then moving, or maybe even starting with the local version. I wonder if you could just talk a little bit about the options that are out there.
Sure, Matt. Yeah, absolutely. So SingleStore has the ability to be deployed both on the cloud or on premise. And we have a managed service solution, which is our SaaS product. That's what we did the actual demo on that we showcased today. So with that, you have the ability to deploy in any of the three major clouds: AWS, Azure, Google Cloud. So you have those three options in a variety of supported regions. And on the flip side, we have kind of our self-managed solution, which is you get licensed units of SingleStore, each having a certain amount of capacity, and you can deploy that on any Linux-based configuration, whether that's on premise with bare metal machines, in your own private cloud, in Kubernetes or Docker, or some other flexible deployment options. And a lot of our customers actually use us in a kind of hybrid format. They might have some development or testing or QA instances hosted locally on premise, and they might have their production instance in the cloud. So a hybrid deployment is something that's super rare in the database market. Typically, companies are either or. So our ability to combine both is something that's a huge plus for customers.
Good stuff. I'll give you one more, Aditya, and then we can go back to Vishwajit. So there's one question that says, what are the scalability features of SingleStore? Does it auto scale? How does the user control that? And then there was another question about, how long does this take in terms of processing? Somebody also asked about Postgres at some point. So I wonder if you could just talk about like the value proposition for SingleStore in terms of scalability and performance.
Absolutely. Yeah. So SingleStore is a very, very scalable database, and that goes for both the cloud product as well as the self-managed one. We can both scale up and scale out. Like I mentioned, we can add more capacity to the machines within an existing deployment, or we could add more parallel machines. And within our cloud, it's a very, very straightforward process. You can do it directly with 2 clicks in the portal UI, where you can just resize your workspace. You can scale up to any size and scale down to any size. And it is a fully online operation. So it won't introduce any kind of application downtime or anything like that. Now, one thing I'll add too is that auto scaling is a feature that we don't have currently, but it is on our roadmap, and it should be coming out early 2025. So a lot of customers have asked for the ability for the instance to auto scale based on traffic patterns and load on the database. So that's something that'll be pretty neat.
Very cool. Vishwajit, I know you've been busy in the chat, or in the Q&A, I should say. Any questions that you see that are outstanding you want to answer live, or any questions you already answered that you want the audience to hear?
I think a lot of people are asking, kind of getting jumbled on, like SingleStore is a database, and this is just one of the applications which we build on top of it. You can build a lot more GenAI applications or your data processing applications, right? Like we are not a resume processing, right? Some people are getting confused over there. So that's one thing. And someone is asking, I think you are replying to that, right? Okay.
Yeah. You have to sign up for OpenAI separately. And I heard that in the past few days, given everything that's going on with OpenAI, that they maybe have paused new signups. So you'll need to sign up for it, but I don't know if you'll be able to do that today.
Yeah. Someone is asking other methods to evaluate a resume, leaving the prompt engineering method used by you. Nothing that I knew of personally. Right. So
I also see, and Aditya, I wonder if you want to answer this. There were some questions about both security, GDPR compliance. Just, I think of these as kind of like the enterprise features of SingleStore. Do you want to talk about that at all?
Yeah, so we have a series of certifications that we've worked hard at and gotten, including GDPR, HIPAA, SOC 2, ISO 270. So we have that all available on both editions of SingleStore, the cloud and self-managed, and we have a series of enterprise-related features, like I spoke about as well, including like role-based access control within our cloud portal, within the database layer itself, down to the table layer, the row layer as well. So you have the ability to essentially deploy and develop multi-tenant SaaS applications where you might be using the database layer to serve hundreds or thousands of actual customers on your own side, and you need to be able to make sure that the data is secure and tenanted and private across all of those entities. So we have all the features to support that.
Awesome. Okay, I know we might have time for one last question before we announce today's AirPods winner. I wonder if either of you want to take this. I saw someone asking about converting the text to JSON, want to build LLM, data security issues. And I know I've heard Akmal talk in the past about, you know, I know we did a webinar on AWS Bedrock. It's the AWS LLM and keeping everything in a safe environment. And I've also I think both Madhukar and Akmal have done LLM apps that are completely local and nothing is being sent to OpenAI. I wonder if either of you have any experience in either of those areas or any thoughts on just like data security when you're working with an LLM?
Yeah, no, it's a really good question. I think there are obviously some security considerations to be wary of when you use an open source like OpenAI. I personally haven't used too many outside of OpenAI. I have used Watsonx's LLM, which is you need essentially like a private account for that. But I'll probably let Vishwa speak to this more in case he has some experience with other private LLMs or things like that.
Yeah, I think Matt, did you refer to this question? Any thought of converting a text file into JSON with information extracted in nested format in JSON file?
That's one of, go ahead.
Yeah, so the user which asked, right, let's say you extract the information by providing, let's say you have a very, very sensitive information. I would personally not recommend using OpenAI. You can rather have a Llama hosted on your private cloud, right? From where you can get your chat completions and embeddings done. If you have a very tight security issues, because few of our customers who are using SingleStore, they basically use their in-house hosted LLM models for embedding generation and chat completions.
Yeah, good stuff. I'm also going to put this webinar answer because we did a webinar on building a private network LLM with AWS. So I'll put that in the chat in case that's helpful. But yeah, we're at the top of the hour. So let's wrap up and announce that AirPods winner. Quick note before we do that. If you enjoyed today's content, I hope you'll join us again on Monday after the Thanksgiving holiday. We're going to be presenting that beginner's guide to Gen AI, LLMs, RAG, and much more. Hopefully you'll join. I just put that RSVP link into the chat. It's the bit.ly link that's there for you, and hopefully I'll see you Monday. The announcement you've been waiting for, AirPods winner goes to Naresh Batula, Senior Engineering Manager at Walmart. Congrats, Naresh. If that's not you, don't give up. We're going to give out one more AirPods by the end of the day to anyone who has tried out Vishwajit's demo. So I put that SingleStore Spaces link in the chat earlier. Put it in there one more time, but I'm also going to email this out to everyone. Everyone will get the recording and these links, these assets by email once it processes in an hour or two. So stay tuned for that. Thanks so much, Vishwajit and Aditya. Awesome presentation. Thank you to our audience for attending, and have a great rest of your day. Bye, everyone.
Thank you so much, everyone.